2022 Exam 1 walkthrough for the course MA 158. Let's begin. Number 1. Given f of x equals 7x minus 3, evaluate f of 0. So this is basically asking us to find f of x when x equals 0, so we're going to plug in 0 for x. So it gives us f of 0 equals 7 times 0 minus 3, or negative 3, giving us an answer of A. Number 2, find the domain of the function f of x equals x minus 1 over the square root of 3x. So when we're trying to find the domain, a common spot where there's a discontinuity in the domain is with fractions, and because this is a fraction, you really need to check that denominator for discontinuities, or essentially where the denominator equals 0 or has a number that does not exist. So the first one I want to check is when this equals 0, because again, if it's any number over 0 that doesn't exist, so we can set the denominator, the square root of 3x, set equal to 0, and we can find from this that x equals 0. So that means that whenever x equals 0, this doesn't exist. Looking at our options, that immediately rules out B, because that means that we can't have it wherever 0 is, because again, if we include 0, that would give us x minus 1 over 0, or it doesn't exist. That also rules out C. And then let's keep going. The one other time this would be inconclusive is whenever whatever's under the root is a negative number, regardless of what that negative number may be. So that first occurs when x is less than 0, because 3 times any number x where x is less than 0 is going to be a negative number. So our domain is 0 to positive infinity, not including 0 again, because if it was 0, we would have 1 over 0, which is inconclusive. So our domain is A. Number 3, simplify the expression 1 over x squared minus 9 plus 7 over x minus 3 over 1 over x minus 3. So with this one, I want to simplify, or basically combine the terms in the numerator. So to do that, I'm going to first start by factoring this denominator to see if there's any like terms. So we go 1 over, and then we need to figure out what this factors into. Well, super neat trick with these ones. This is called a difference of squares. Difference of squares shows up as this, x squared minus b squared, and then that splits into a minus b and a plus b. So you can actually test this. You can see that if we distribute, right, you get a squared and then plus ab minus ab, and then plus b squared, leaving us again with a squared plus b. In this case, our a is equal to x, and our b is equal to the square root of 9, or 3. Now, if we write this in our little thing right here, we can see that we have a minus b, so that's x minus 3, and then a plus b, x plus 3. And then we're going to add the 7 over x minus 3, put it all over 1 over x minus 3. The next step is we can see that if we want to combine this term and this term, we need to multiply this term by x plus 3. So let's go ahead and do that. So we have 1 plus 7 times x plus 3 over x minus 3 times x plus 3. And then what I want to do with this is, if you're dividing by a fraction, you basically just have to flip it so it's the reciprocal. So this part right here would actually be equal to multiplying the numerator by x minus 3. So we're going to simplify a little bit. Let's go ahead and simplify the numerator. So it'll be 1 plus 7x plus 7 times 3 is 21 over x minus 3 times x plus 3 all times x minus 3. We can see that the numerator, or the denominator, has this term and the numerator has this term, and these are like terms, so we can actually cancel them out. So if we cancel them out, we are left with 1 plus 7x plus 21 over x plus 3. Simplify the numerator one more time, and we have 7x plus 22 over x plus 3. If we look at our answer choices, that gives us an answer of F. Number 4, rationalize the roots in the expression 3 root x plus the square root of x minus 9 over 4 plus x. So when we're rationalizing roots, we want to use the conjugate. That basically just means flipping the sign here in the middle. So to find this, we're going to multiply by the conjugate. So if I rewrite this, right, you see that the conjugate is 3 root x minus the square root of x minus 9. And then we can't just multiply by any random number, but we can multiply by 1. So if the numerator and denominator are the same, then we're multiplying by 1. So we're going to repeat that on the denominator. Now I'm going to distribute the numerator. So this term to this term is 3 times 3 is 9. Root x times root x is x. And then this right here, minus 3 root x times the square root of x minus 9. Then here we have plus 3 root x at root x minus 9. And then finally, minus x minus 9. And then all over 4 plus x times 3 root x minus the square root of x minus 9. Now, we can simplify a little bit. We can cancel these middle terms. And we're left with 9x minus x minus 9. But because we're subtracting, we need to distribute this negative sign. So it should be plus 9 all over 4 plus x. And then times 3 root x minus x minus 9. Simplify one more time to get that numerator down to the final answer, and we get 8x plus 9 over 4 plus x times 3 root x minus square root of x minus 9. If we look at our answer choices, that gives us an answer of F. So whenever we're asked to rationalize roots, remember, multiply by the conjugate to basically remove the roots. Number 5. Factor and simplify the expression x minus 13 squared times 7x plus 10 to the 9th plus x minus 13 times 7x plus 10 to the 4th. Man, that's a mouthful. So when we're factoring, we want to take out as many like terms as we can. So if we look at this, we realize that both of these terms have an x minus 13 and a 7x plus 10 to the 4th. But we notice the different powers. So what we want to do for this specific problem is we actually want to remove the highest power of each one. So in this case, this x minus 13, right, the highest power is 1. So we're going to write out x minus 13. And then the highest power for the second term, the 7x plus 10, is 4. So we're going to write 7x plus, or 10 to the 4th, times, if we take this x minus 13 times 7x plus 10 to the 4th out of this first term, we would get x minus 13 and then times 7x plus 10 to the 5th. It is to the 5th because 9 minus this 4 here, if we're taking 7x plus 10s out of 9, 7x plus 10s, then we're going to be left with 5. So this will be 7x plus 10 to the 5th. Plus the second term, if we take out an x minus 13 times 7x plus 10 to the 4th out of this second term right here, we're just left with number 1 because we got rid of all the terms. Now if we look at our answers, I'm going to clean this up a little bit so that it's easier to read some of my exponents. We can see that our answer matches up with A. So when you're doing this, just be careful to pull out the right number of terms from each part. 6. Given f of x equals 7x minus 3 and g of x equals x cubed, find f of g of 2. So this is like a composite function. So this means f of g. So what I like to do is use a f of g of x. So I like to rewrite it like this to remind myself of what it looks like. Now, that means we need to plug this x cubed in for x in this f of x function. So let's go ahead and do that. 7 times x cubed minus 3 is f of x. And it wants us to find it at 2, so now we just need to plug in 2 for x. F of 2 equals 7 times 2 cubed minus 3. So that's 7 times 8 minus 3, which equals 56 minus 3, which is 53, or an answer of A. 7. Given f of x equals 8x minus 1 and g of x equals 3 over x squared, find g of f of x. So this is g of f of x. That means we need to plug this function f of x into the x for g. So if we do that, we can see that it's 3 over and then 8x minus 1, because again we're replacing the 8x plus minus 1 for the x in g. That whole quantity squared. Luckily we don't have to plug anything in. If we look at our answer choices, that gives us an answer of A. Number 8. Given f of x equals 10x squared plus 8x minus 1 and g of x equaling 1 over x, evaluate 3f of 2 plus 6g of 1. So what I'm going to do first is actually find these quantities right here, this f of 2 and this g of 1. So we just need to plug in 2 into this f of x equation and 1 into this g of x equation. So f of 2 equals 10 times 2 squared plus 8 times 2 minus 1. So that gives us 40 plus 16 minus 1, or 40, not 45, 55 for f of 2. And then for g of 1, we get that it's 1 over 1 or equal to 1. Now we just need to plug in this value and this value into this. So we get 3 times f of 2, which is 55, plus 6 times g of 1, which is 1. And that's 55, which is times 3, which is 165, plus 6, that equals 171, or an answer of F. Given f of x equals x squared minus 3 and g of x equals 1 over x squared, find the domain of f of g of x. So again, I'm going to rewrite this to help me see it a little bit better. F of g of x, we put the function g of x in for x in the f of x equation. So we put this in here. Now if we do that, we get f of x, or technically f of g of x equal to 1 over x squared, the whole quantity squared, minus 3. Simplify that, we get 1 over x to the fourth minus 3. Now we need to find the domain. The one big thing that sticks out to me with domain, right, is that you want to look at fractions really closely. One thing that sticks out to me is this denominator right here. Basically, that quantity does not exist when this denominator equals 0. So that means that x equals 0. This doesn't exist, which means that the domain must be negative infinity to 0 and 0 to infinity. Basically just not including that 0, because there are no other places or no other fractions where fractions or roots where there could be discontinuities in there. So looking at our answers, that gives us an answer of F. Given f of x equals 14x plus 2, find and simplify the difference quotient of f x plus h minus f of x over h. So with this, we just need to plug x plus h into f of x. So that gives us f of x plus h equal to 14x plus h plus 2. And then f of x is the same as it is, so we just need to plug this here back into this. If we do that, we get 14x x plus h plus 2 minus f of x, which is 14x plus 2 all over h. Let's simplify. 14x plus 14h plus 2 minus 14x minus 2. Don't forget to distribute that negative sign all over h. And then simplify some more. We can see that they're like terms. The 14x's cancel and the 2's cancel as well. So we are left with 14h over h, which equals 14, giving us an answer of E. Number 11. Compute the average rate of change of the function f of x equals x squared plus 2 over the interval of 3 to 5. So when we are looking for average rate of change, it's just a fancy word of saying the slope. Now, if we remember our slope equation, it's y2 minus y1 over x2 minus x1. We're given 2 points. We just need to figure out the y1 and y2 from said 2 points. So let's start with 5. So f of 5 equals 5 squared plus 2, or 25 plus 2, or 27. And then f of 3, or our y1, equals 3 squared plus 2, or 9 plus 2, and that equals 11. If we plug in f of 5 for y of 2 and f of 3 for y of 1, and then 5 for x of 2 and 3 for x of 1, we should be able to find our slope or average rate of change. So let's do that. So y2 is 27 minus y1, 11 over 5 minus 3. So we have 16 over 2, or 8, which gives us an answer of D. Number 12. Find the domain of the function of f of x equals 11, 3x minus 4 plus 15x plus 7. With domains, again, pay really close attention to fractions and roots. I can see that roots will be the issue in this problem. There are no other fractions in here. So let's go ahead and set these roots equal to 0, because 0 or anything less than 0 will cause these roots to be imaginary. So let's set this equal to 0. 3x minus 4 equals 0. That gives us 3x equals 4. X equals 4 thirds. Let's do the other root. We get 15x plus 7 equals 0. 15x equals negative 7. X equals negative 7 over 15. Now, we want to find the domain. What we do know is that any number less than this or less than this will cause it to be imaginary. So we need to go with the bigger number of the two to ensure that both of these roots stay 0 or positive the entire time. Because 4 thirds is greater than negative 7/15, we're going to go with that for our domain. Again, anything smaller than 4 thirds is going to cause it to be imaginary, so our domain has to be from 4 thirds onward. So 4 thirds to infinity. Now, is it inclusive or not inclusive? Just because the value under the root is 0 doesn't mean it's imaginary. So it is inclusive of the 4 thirds. So we're going to use a bracket instead of a parentheses. So our domain is 4 thirds to infinity, giving us an answer of C. I want to reiterate again that we have to keep both of these values in the roots 0 or greater. In this case, 4 thirds is a larger value than negative 7/15, meaning that we have to keep this value of 4 thirds or greater, or else that this first root would become imaginary. 13. Given f of x equals 3x squared plus 2x, find and simplify f of t plus 1. So f of t plus 1, we need to plug in this t plus 1 in for these x values. So f of t plus 1 equals 3 times t plus 1 squared plus 2 times t plus 1. Now, we simplify, or we start by distributing this So I'm going to say 3t plus 1 times t plus 1 times, or plus 2 times t plus 1. I'm going to distribute. So we have 3 times t squared, and then t times 1 is t, so plus t. 1 times t is t, so plus t. And then 1 times 1 is 1, so plus 1. Plus 2t plus 2. Now we just got to simplify some more. And we have 3t squared plus, this is 2t, so 2 times 3 is 6, so 6t plus 3 plus 2t plus 2. Simplify again. 3t squared plus 6t and 2t, those added together are 8t plus 3 plus 2 is 5. If we look at our answers, that gives us an answer of A. Number 14. A spherical balloon is inflated to the surface area S is increasing at a rate of 4 meters squared per second. Express the balloon's radius in meters as a function of time in seconds. So, the one thing I'd like to point out is surface area equals 4 pi r squared. This here is a rate. So that means that it's times second. So, if we look at this S right here, we want to plug in what the actual surface area will be, but surface area is not in the units of meters squared per second. So now we need to multiply by t, or time, to cancel out this seconds unit in the denominator. So that gives us a S equaling 4t meters squared. Again, we're multiplying by t because t has a unit of seconds, canceling out the seconds in the unit of the increasing rate. So if we plug this in for S in our equation, we get 4t equals 4 pi r squared. Now we need to solve for r because we're asked for the radius in meters as a function of time. We can divide 4 pi out to this side, and we get r squared equals 4t over 4 pi. Cancel out the 4's. If we take the square root, we get r equals the root of t over pi. If we look at our answers, that gives us C. Again, watch your units. With these rate questions, we're going to multiply against t to get rid of that extra unit of time, or get rid of the unit of seconds in that rate. Now, the last question. The population of Demogorgons in Hawkins, Indiana can be modeled by the function d of t equals 20t squared t plus 6, where t represents the number of years since 2016. Find the population of Demogorgons in Hawkins in 2022. Round to the nearest integer if necessary. So, with this question, we need to basically find the amount of Demogorgons in 2022. So if we look at this, right, we can't just plug in 2022. It's saying the amount of years since 2016. The amount of years since 2022 is 6 years after 2016, so our t equals 6. Again, that's 2022 minus 2016 equals 6. With these word problems, we want to make sure that we really pay attention to when that start time is, especially when it's associating with years. So if we plug in t equals 6 into this function right here, we should get the amount of Demogorgons. So we have d of 6 equals 20 times 6 squared over 6 plus 6, which equals 720 if you plug that into your calculator, over 12, and that equals 60, giving us an answer of C. Again, make sure to pay attention to your years when you're given these word questions.